All right, welcome to another Open Source Friday. I am B Dougie, your host, and today we've got a special guest, which is Phil. So I'm curious, like, if you could shed some light to what is URQL and what are people using it for?
Yeah, I'm glad you actually heard about it and were told about it. I guess the name thing is a bit unfortunate, but the name has started a bit of a joke. But it's a GraphQL client, and I see it as kind of the third GraphQL client. And people could get mad at me for saying that. There are obviously a lot more attempts at creating GraphQL clients, and our attempt has also started quite humble. So initially, we just wanted to experiment with GraphQL, see, what was the bare minimum that a client should be able to do. And at the time, like so many others, we've used Apollo's client. And we had some frustration and snags every now and then, and we just wanted to see what goes into making a client. And we started from a very small base and then grew it from there, which also means that we had a very different approach to it than maybe Relay and Apollo. I would say in a certain sense, maybe if Relay is on one side of the axis and Relay is very opinionated, then Apollo would be on the other side and very unopinionated. And I would say URQL kind of slides in between being opinionated and unopinionated. I guess we could talk about that. So I guess more importantly, where I was at was actually when we go to the React API, and we have bindings for Vue, Svelte, and Preact as well. Well, React Native, we just use the React bindings. I'm specifically showing the React ones because once we go into an example, we can actually see this may as well be Apollo code, and that's because bindings to a certain extent are pretty unopinionated. There's only so many ways to write these query hooks. I mean, we're passing it a GraphQL query. We kind of need a name for sending a query. So that's going to be use query. And then we get a result. There are some differences in like the API, as in, I think in Apollo, you'd pass the query string or the document as the first argument. You're getting the result back as one object. So there are some superficial differences, but those are ultimately just small choices. What's more important, I guess, is how we then approach our default behavior. Our default behavior is much leaner.
Yeah, and there's a question in the chat already, actually a couple questions to chat, but I'll grab the second one because I think it's more relevant to what we're talking about now, what do you see the biggest advantages comparison to Apollo and Relay for, actually, the advantages over Apollo for everyday React users?
Right. I believe the interesting thing about URQL is that when you're just getting started, especially when you're new to GraphQL, you're getting a GraphQL client with URQL that is much simpler when you're just installing it. And one of the things that is different then is actually the caching approach, because by default, you're getting a very similar document cache approach. And that's kind of more like how a browser caches. So it takes your query, it takes your variables, it gives you a result. And this result is cached as if it was like a REST API response by a browser. And the only thing that we then add on top is when you send a mutation, so when you modify some data, it just matches the type name and invalidates queries. So the nice thing is, for anyone that's kind of new to this, in GraphQL, we have this type name field. And whenever we're asking for a set of data, we can send that off, and URQL can add that on automatically. So we can actually inquire the API what type something is. And using that for cache invalidation is actually already so intuitive that for a lot of simple apps, like for instance, blogs, news sites, like sites with basically mostly static-ish content, that's good enough. So then you're starting off from a very simple, minimal kind of starting point. And that's when you can add on extensions. In URQL, those are called exchanges. In Apollo, those are called links. And they're ultimately pretty similar, which is why I'm comparing them. But in URQL, they get a bit more power because even caching in URQL is actually just an exchange. So the only abstraction that you have to think about at a certain point is what exchanges do I add? So the advantage you get is that you have a lot of these features. And when we go to this advanced section, all of these are basically add-ons. So all of these things are things I could add on to an URQL client. You can add those step by step. So you can kind of customize the client as you're going and as you need. And all of these are kind of layered on top of what you already get when you're just kind of browsing around, building a simple app like that. And then later on, you could even drop in normalized caching. So that's very different from Relay and Apollo, because we believe that normalized caching doesn't have to be, in there from the start.
Excellent. Yeah. So appreciate you taking that slight detour. But can you talk more about like things like the difference in normalized caching? Because I don't even know if I have my brain wrapped around how you're approaching this.
Right. I guess I have actually recently given a talk about this.
Excellent.
So that's why I have a slide deck ready. Where did this come from?
Like a great dev
I don't know. So these are actually our guiding principles. And the reason why I'm bringing them up is I've kind of touched on that very briefly, because when you're coming to URQL, it might be a little odd to hear, oh, okay, caching is not that opinionated. Like you don't really ship with opinions. And these are kind of the things we've ended up on. The middle one here says unopinionated and flexible. So what we've kind of settled on is we don't really want to force any opinions on people that use URQL. So like you say, it's really intuitive to get started with something that has that SWR logic where you're just fetching and then it just aggressively invalidates. So basically just, calls your API whenever some data needs to be updated, simply said. And then later on for like more complex applications, that's when you need to use something like normalized caching, maybe, but you don't want to be forced into it right away because you might not even get the benefits of it. Instead, you would be forced into understanding it at the wrong point in time when you're not even interested. And that's kind of the third point here, intuitive when extended. So any kind of exchanges and extensions that you drop in, the idea is that URQL starts out as unopinionated as possible. But as soon as you drop these things in, that's when we are kind of buying into some of our opinions, at least. So what I'd like to think is our normalized caching implementation, for instance, is actually a little more opinionated than Apollo's. And that's because we want to enable a couple of features and still make it pretty intuitive. And that comes with a bunch of opinions, which I'm going to be honest, can introduce some friction if you're coming from Apollo, because you might be expecting to do things a certain way. And then, it might not work out well. But that's why we have GitHub discussions. So we see a couple of people basically posting Apollo code and asking us, hey, how do I write this in URQL? But if I quickly scroll through this, I have a slide somewhere in here about caching. Here it comes. So this is the kind of short summary of this. If I make this larger, that might be easier. So the whole idea here is, and this is the short explanation, document caching caches like a browser. So you're fetching documents. And each query result, so every time we're sending a query, that's basically what we're saying is a document. And then these query results are invalidated, so refetched, whenever a mutation has kind of contained some similar data. So whenever it shares a type name with a mutation, that's when a query is invalidated and fetched. So that's the basically smallest amount of caching and invalidation one can do without like introducing you when you're just playing around with URQL to bugs where something might not be invalidated and you're kind of stuck with a sticky cache. So that'll be annoying. And normalized caching, on the other hand, is the complete opposite. A normalized cache keeps data around for as long as possible, and it caches like a database. So it's basically an in-memory database. It builds up tables of these objects from your API automatically. So everything's split by the type that is already set up on your GraphQL API. And then any changes on like one object, so one entity with the same ID field maybe, is shared across every query. So you're getting a lot of updates as soon as you're fetching different stuff from the API. But as soon as you use normalized caching, it doesn't invalidate automatically anymore. Instead, you're encouraged to let it update. But sometimes you have to help it out with a couple of updates. Right. We're big fans of GitHub, obviously. I don't need to really say that. But I was working hard on trying to get early access to GitHub discussions. We came from Spectrum.
Okay.
And now that this is kind of its replacement, it's really living up to it. And we really wanted this after I think I've seen how it was used on the Next.js repo.
Yeah.
And we're getting a lot of questions. And I'm kind of used to that. I'm a core contributor to Start Converters as well. And there were really like overflooded at like above the limit in terms of how many questions come in.
Yeah.
So just having this one hub where all the questions come in, having answered marks, having it be searchable has helped so much. Ever since we've activated it, we actually have gotten less questions. I assume because it's so searchable. Right. This is pretty early days.
Yep.
We are actually working on new examples, and for that, we're building a new demo API. This whole thing here, try GraphQL, that's just all temporary. So don't worry too much about the app itself and the UI. This is just a vessel, kind of get this out. But this is basically just a simple GraphQL API. So I can start typing some stuff in here. So for instance, I've selected the basic Pokedex API. I can just list out Pokemons. Let's list out 10 Pokemons by name, the 10 first ones. Sure. So that's not too interesting. But under the hood, this is actually using URQL. So while not that interesting, we can actually go into the code, which is right here, and we don't worry about this. This is kind of the code that creates the client. And while a lot is in here, this demo shows multiple APIs. So a lot of this is actually not relevant. We can go and delete a couple of things. Now, this is kind of how we can create a client. I guess I can make it even simpler. We have kind of like just this setup. So let me make it a bit larger. The basic thing here is if you were to create an URQL client, you would drop in 3 exchanges. You would drop in the dedupe exchange, the cache exchange, and the fetch exchange. If we leave all of this out, so if I were to remove this, this is also what it would add by default.
Yeah.
So what this does is it makes sure we're not sending duplicate queries to our API because that'll be unnecessary. This is the document cache I've mentioned. And then lastly, we're just dropping in the fetch exchange, which knows how to use the fetch API to send API requests. So that's not very interesting, but things like our devtools are integrated using these exchanges. So if I drop in the devtools exchange and I go back here and we give this a little refresh, I can actually open this devtools tab. All that's interesting here is this is all an extension. You can install the URQL extension, and then if I start fetching things, we can start seeing some kind of events pop up in here.
Yeah.
So as I'm sending this, or if I say I want to actually remove the ID here, that's when it pops these things into this inspector. And I can actually see all of these in here as well. And that's kind of our first way of getting a more visual overview of what's going on in an app. So we can see the same response here, but the same response is kind of sorted by data. So here we see Pokemon's limit 10. But if I were to now say skip 10, so we get the next 10, I can see that separately. So it kind of starts collecting this data over time. Right, exactly. So this is a browser extension. And once you install the URQL browser extension, so you can go to the Chrome store, the Firefox extension store, you just search URQL, this will pop up. Or at least it should. I mean, URQL, a unique combination of 4 letters. So yes. Hopefully that works. Then when you, in your app, drop in the devtools exchange, that will enable it to integrate into your app. So a bunch of things. I have more APIs here using which we can demo a couple of things. So for instance, this is a colors API. This colors API is not too exciting, but I can tell it to give me a random color by name and a hex code. That's not very useful for demoing, but as you'll quickly see, this API misbehaves a bit for testing purposes. So this API actually has a 66% chance of giving me a very unhelpful no soup error.
Okay.
Which, look, I mean, no soup for you. So that gives me the opportunity to kind of show a bit more about how you would build on this. I can actually install the retry exchange, and I can add retrying to URQL. And that will allow me to basically get around the fact that this API is sending some errors. Now, this API is pretty contrived. I know it has a very high chance of giving us very unhelpful errors.
Yeah.
But Sometimes you need to actually handle errors well, or at least avoid getting more of them. I think it has some default stuff. So I think this is actually all I need. Let's go back and see. I think I need to tell it when to, yeah, okay. Fair enough. Ignore that. I need to actually tell it which errors to react to. By default, it actually only reacts to network errors, which is because if you're getting a random 500 error from your API because something's gone wrong with some routing, then you could just drop in the retry exchange and everything would be fine. In this case, I actually want to write this small function. I'm just going to trim that down. In this case, I want to tell it to specifically watch out for this no soup error. So if we compare this, we can see in the API that, so now if we go to the network tab, we can actually see it sent a bunch more requests than we expected. So we can see that it got an error at some point, but it retried again because we've added the retry exchange. So this kind of composability is what we want. We want to be able to have these changes be very easy to add. So if you go to the docs, this would actually be under advanced. You will actually find under retrying operations. So the idea is almost each of these sections has an exchange that is useful for a certain case, but you don't need to worry about this when you're starting out, but instead you can explore this. So it's not unlikely that you would probably at some point be searching for how do I retry failed operations. And you could go here, you can go to retry operations. Here we can see this is exactly what I've just added. A retry exchange with retry if and a bunch of other configs. Has a bunch more options, which are really just fancy delay options, which we do not need. Yeah, there's a bunch more like that.
Yeah, that seems approachable and intuitive too as well. Like there's some things that I've done in GraphQL that I've had to do some like weird hacks to make work. Like retrying is something that, again, I've been using GraphQL since almost the beginning. So the advancing in tooling has made using GraphQL so much more easier. So I'm happy to hopefully try this out in a future project. There was a question, actually just came in. Do you consider cores as a thing within GraphQL?
Well, I mean, it is a thing, right? So I need to make sure that the API I'm pinging here, which is actually not running locally. So if I go here, it's actually running on a demo URL. The domain is not important. It does need to send some course headers. So only a single one in this case, so it's not a big deal. But it's not really in our scope since we're not dealing with the backend, since URQL is just a client. So it's not a topic in our docs. It is important for this demo.
Yeah, which is a good distinction too as well, because like we did mention Apollo a few times, and Apollo is one client that does also have a server component as well. So this is specifically for consuming GraphQL endpoints into your front end or mobile apps, and like I guess honestly, front end mobile clients, any sort of client would be like I'm using OBS right now to stream this, so that would technically be a client as well. That does not very friendly to GraphQL.
That's for sure. Yeah, it's interesting. But I guess one more thing we can do is
sure.
I did mention the cache exchanges here. So what I can just do is, in case you would want to get started with normalized caching, all we'd have to do is install GraphCache. So that's what we call our normalized cache. Sounds a bit fancier than normalized cache and shorter, so that's important. So what I would do is I need to import cache exchange from that package, so URQL exchange GraphCache. And now we can get rid of the other cache exchange. We don't really care about it anymore. And this here changes the meaning now. Instead of just dropping it in, we're actually getting a bunch of options on the cache exchange now. And if you're just getting started with the normalized cache, to kind of get the same default behavior they would expect from a normalized cache, you don't need to pass in any options. So once we drop this in, we could, I guess, go to the basic Pokedex API. That's a jolly good one. Would help start the server back up. Is it kind of? Yeah. Right. So once that's set up, we shouldn't see any difference initially. So it should, for instance, still be able to say Pokemon's limit 10 ID name. So once we do that, We're kind of just fetching Pokemons, we're getting them. That's not a big deal. But an interesting thing happens, for instance, if I leave out name. We can see it executed it, but no new network request came in. So that's the big advantage. Now that we have a normalized cache, it can start executing some GraphQL caching locally. It already knows about a bunch of this stuff, a bunch of this data. So it doesn't need to go back to the API. And this kind of is all done in the background automatically. But there is a caveat. It doesn't know about any kind of other stuff, any kind of links that you set up yourself. So while we know about Pokemon 001, and we know we've seen it, we can in fact still see it on the right here. GraphCache doesn't know how to actually get to it if we change up our query. So here I'm now saying I want a single Pokemon with the ID 001. And if I execute that, it had to go back to the API, although it had all the data it needed.
Interesting.
And that's kind of the case when you kind of need to tell it what to do. So you need to teach it some smarts.
Gotcha.
Which isn't too hard. It's very similar to how you set up a GraphQL server API. So if we go to Cache Exchange, we can create resolver configs. And there on query, I can actually tell it what to do when it gets Pokemon. It sounds really weird. I can tell it what to do when it gets Pokemon. Yeah, sure, Phil. I know that a GraphQL resolver in the backend and in GraphCache is parent, arguments, and then so on. But it's easy to forget. I don't want to try it out twice. So let's just refresh. So we're going to do the same thing again. I'm going to get some Pokemons, 10 in fact. It's always a good amount. Let's also get, I guess, the types here. So we're getting the types of Pokemon. So that has worked. We set up our Bulbasaur on number 1. And what we're now looking out for is it's done this one request to get all of these Pokemon. But now if I do ID 001, there we go. Now I can see it's gotten that one Pokemon and it has sent no network request. So I can go type in a different ID, I can get a different Pokemon. So that's the power of a normalized cache. As long as you're basically aware of what you're trying to do, you can get data entirely offline, well, without going to the API if your offline cache already knows about it. If GraphCache knows about it, it can probably get it. Sometimes you do need to tell it how certain resolvers work. This is an important example because if we're imagining this was some kind of blog and we're seeing a list of blog posts, we might have already fetched like the title of that blog post and like a short description or an image. But once we click on that blog post, we're going to the next page. And that's when we're seeing the details page with all the content. And a normalized cache can still be useful in that scenario because you could teach it to kind of show a bunch of that data before you actually have loaded the rest of it. And that's a concept that we're actually calling schema awareness. So there is this page that kind of explains you how to set it up. But this diagram is mostly what it is. So this is what I've just described. We have a listing page. We're going to a details page. The idea is GraphCache should be able to give you part of that page until it has fetched the rest. And that pairs really well actually with the suspense concepts in React and Vue 3.
Yeah.
Because that really allows you to set up loading pages more dynamically. So you can kind of leave out a bunch of bits here and there.
Yeah, excellent. Yeah, I'm using Suspense in one of my apps that's leveraging GraphQL, specifically the open source app, and it has been a pain point of like trying to figure out how to pass data around as I'm trying to navigate the different sections of the app. So light bulbs have gone off with just your simple Pokemon example of how you're teaching the cache to fetch the data that is similar, I guess. Because I have basically, and my concept is I have a list of repositories. Open source is it's a project to encourage open source contributions, and I think the best thing for me to do is this. I'll switch to my screen share for a second. But when you first load this, I have a list of repositories that I'm sort of tracking on GitHub, and then when I click through PizzaQL, and now I get some data that gets loaded. So like this is consistent but well, that takes me to the repo. Everybody check out Pizza QL. It's a great way to order pizza through GraphQL. But with this, like the URL that I have here or the name, I have to add it to I'm actually pulling it from here because I didn't have a way to properly cache this. And possibly there's a great way to do this in Apollo today because I'm using Apollo here. I just haven't had the time to go learn it to then fix it in this app. So that's basically where I'm at. Like I probably have a solution for this. I just haven't done it yet. So my project's open source. Definitely check it out if you want to help solve problems for me. But going back to URQL, I love your example because I feel like I could, if I just took a time to think about it, I can leverage that example to help teach me to fix that problem.
Yeah, it's an interesting one. I think this diagram is an interesting one because it takes a bit to explain the whole idea of, oh, give me partial data and like have schema awareness. We like came up with like short but like hand wavy terms for it. And it took us a while to figure out this is the one example that most people have seen, that most people understand.
Yeah.
Now, the reason why it's called schema awareness is I have left out a small but important bit of what you need to do to make your pizza QL example work.
Yeah.
It's called schema awareness because for partial data to work, we need to actually introspect our schema. Sounds pretty scary, but it's a pretty common process. In fact, in this demo, all of this info down here, where it like lists what this GraphQL schema can do for Pokemons, that's introspection. And that's just a normal GraphQL query where we're just asking the GraphQL schema, hey, what bunch of types do you have? Like, what do you know? What can you do? And for schema awareness to work, we're kind of taking advantage of that data as well. So the only piece of data that a normalized cache usually needs is that type name field. So it needs to know, hey, this object is a Pokemon, or this object is an evolution of a Pokemon. I think we do have that in there. But as you kind of go along, there are two types of information that you add. So first of all, you set up configuration to kind of set up resolvers. So you're teaching the cache what to do in certain circumstances. You can set up updates to kind of teach it what to do in mutations. And we have this entire page of explaining when you set up what. And these are all very brief sections. So these sections down here are all the ones that you would need to kind of understand these concepts. So we've kind of already seen resolvers. Great, half the thing is done. This is the update section. So it's similar to resolvers. If you're, for instance, adding a new to-do to a to-do list, normalized cache wouldn't automatically know that it needs to add that to a different query. So you need to tell it, hey, this is the query where you need to add it. But partial data is an interesting one because partial data is a pretty useful case where you need more information about your schema. I think in Apollo, you can actually force the cache to give you everything it knows, even if that doesn't fit your query and your schema. And that's an important distinction because do you actually want to get data that the cache doesn't have as null? So if we're thinking about what a GraphQL API does when an error occurs, that field might either be required or optional. When it's optional and that field errors, the server can just set it to null. Cool, it can leave it out. But if it's required, it actually needs to cascade up. It needs to check that parent field and its parent field. Can I set that to null? So there is a small process involved when kind of dealing with partial data on the server side. And that's why partial data can be a bit dangerous on the front end, because you might be generating types for your schema. So TypeScript may be telling you, hey, this field is not optional. You can just trust that that will always be set.
Yeah.
Which isn't the case when you're telling the cache to give you partial data. In fact, we have this RFC board where we're tracking everything we're doing. So while I can't predict what good new ideas might come from people browsing the repo, I can only encourage people to create RFCs, because when you create a new issue, you're also immediately encouraged to create an RFC. And remember GitHub before this feature, it was wild.
Sorry, you have RFCs in your discussions?
Yeah, we have RFCs just as issues. So when anyone has an idea, that might be you, dear viewer, or you, I mean, you can just go in here, you can write an RFC, we'll get to it. And that can start a discussion.
Yeah.
And we'll put it onto this project board so that we can track what's going on. And we don't do this with external ideas or external contributions. We do this with anything we do.
Yeah.
So you can see the examples I've talked about. That's a task that's in progress. And that started as an RFC sent in from an external contributor, which is beautiful. Someone proposed something and we can just do it. Similarly, there are a lot of different ones that we created as well, a lot of ones that come in externally. But there is actually one that we haven't quite started yet. We wanted to do a cross-tab exchange. So we're thinking if two tabs are open with an URQL client, they could send each other the API results they've gotten from the API. So even across tabs, it wouldn't be doing work twice. We haven't really started this yet, but the RFC is there if anyone does pick it up. I think we just didn't start it because there were other things that we wanted to do first. So this was always like the lowest priority one. But yeah, there is an open RFC process. It's all in issues and that project board. We have a very long contributing README that kind of tells you about this. So if you later on want to find out how this works, how do I propose changes, is the section in there that's relevant.
Excellent. Yeah, I mean, that's like the contributing MD sounds like a great place to get started for sure. I'm super happy to see y'all leveraging discussions so well, and then RFCs on project boards. Really easy way to sort of grok for someone who's just coming in for the first time and just learned of URQL or haven't had a reason to try it out until today. So, Phil, thanks so much for the conversation, the examples. I would say, where can people find you? But they obviously find you on GitHub /kitten. But I guess the other question is, where can folks find more conversations like this? You mentioned you had a talk that you gave with the slides that you showed.
Right. I guess there are two things I can shout out, which is if you want to find out more about how the normalized cache works. And, you know, I've talked a lot about this, but the normalized cache was kind of the main thing I've talked about. Then you can go to my blog, KittenSH, and I have an article that explains more about how it works.
Excellent.
Other than that, go to the docs, obviously. If you want to learn more, the docs are a good place to start. formidable.com/open-source/URQL. If you go to my Twitter, and I'll add this in more places later on because this has just been published, you can actually find me tweeting out the talk recording soon. I haven't tweeted it out yet because it's just been uploaded yesterday.
Okay.
If you're really eager, go to YouTube, find Prisma. And big thanks to Prisma for being awesome in terms of organizing meetups and making an awesome ORM. They've just launched a product hunt. If you're on product hunt, give them an upvote. They're pretty cool people. There you can find the talks from that meetup. And that's mine.